Until the beginning of the 20th century, physics was governed by the laws of Isaac Newton. The English physicists and mathematicians said that gravity was a force caused by the mass of objects and made them attracted towards each other. The object with the most mass attracts more intensely. That's why we stay on Earth's ground. She draws us to a center. That's also why the planets move around the sun. But imagine that the sun all of a sudden disappeared and was gone. According to Newton's theory, the planets in the solar system would immediately leave their orbits, as there would be no more of the sun's gravitational force attracting them. For him, gravity was a force of immediate action, regardless of the distance between bodies. But Einstein found a problem. According to his calculations, light was the fastest thing in the universe. Body with mass can reach a higher speed than not even the force of gravity. The sunlight takes about 8 minutes to cover the almost 93 million miles separating it from the Earth. So, if the sun disappeared, how could it be possible for the Earth to be released from its garden before people here let the sun shine? Problems of this nature led Einstein to believe that gravity could have a different explanation than Newton thought. In the 10 years he spent thinking about it, between 1905 and 1915, the German physicist created the theory of general relativity. He imagined the 3 dimensions of space and the time dimension together, forming a kind of tissue that surrounds us and is deformed by the presence of shapes. And he called this space-time. When we apply this thought to planets and stars, what if a heavy ball was placed in the middle of the trampoline? The ball makes the fabric bend, right? It's this coexistence that creates what we feel as gravity. So the Earth and the other planets stay in orbit, not because the sun just attracts them, as Newton thought, but for Einstein. This happens because the sun is such a massive star that the other forms follow the curvature it generates in the fabric of space-time. From there on, gravity can no longer be considered an attractive force between the two bodies. As it was said, Newton, it's the effect that the share of space-time has on the planets. Thinking about it, what would happen if the sun disappeared? According to Instagram, the disturbance this would cause in space-time would form a gravitational wave that would travel to the planets. According to his calculations, this wave travels exactly at the same speed as light. That's why we would stop seeing the sun shine at the same time as Earth changes its orbit. In other words, what Einstein showed is that we were seeing the universe in the wrong way until then. The theory turned him into a worldwide celebrity. Because of him, science and our imagination were able to soar ever higher. And to this day, general relativity continues to surprise scientists and fascinate us all.